Now, last week we established one thing, that is the centripetal force is not an additional force. Okay. Now let's consider some examples of objects performing circular motion. Okay. Now we don't mark centripetal force as an additional force. We have to figure out in the among the existing forces. Now let's start with something like this. Imagine an object rotating like this. Imagine an object is rotating like this, people. Okay. Okay, like this. Sorry, you might have seen. Okay, in a merry-go-round or something like that. Not a merry-go-round. What do you call this? You don't call it a merry-go-round. There's a name for this. I can't remember. Right, like this. Okay, so this rotates. This thing rotates like this. I can't remember the name for this, people. Now, tell me. Let's. This is the same object rotating at moving at different places. Huh? Right, fine. Now, so let's focus on this point. Yeah. Tell me how many forces acting on this object. How many forces acting on the object? How many forces acting on this object is? Hurry up. The object is performing circular motion. Huh? See? How many forces acting on the object? Okay, I have two answers, one from Deepak and one from Krishnika. Okay, Yusuf and one from Krishnika. Out of those three, only one is correct. Four. I have four responses, only one is correct. Right. Azra, Krishnika, and Samhas Lukmano. Their answers are correct. Okay, there are only two forces. There are only two forces. What are they? One is the weight and one is the tension. And what is the other force? What is the other force, people? There is no other, there isn't any other force. There isn't any other force because you have to go with the basic forces, and the object is rotating like this. And you can see the circular path like this. So what you need to do is you need to take the components of the forces so that it's directed towards the center. Now, if you take the angle here as theta, this is theta. This is theta. No, it's like this. To make it rotate, you push it and you take your hand away. No, you push it first and you take your hand away. Then it will keep rotating like this. Okay, I can understand your point. So the force that makes it rotate, you give a force, then you take your hand away, right? You throw it and you take your hand away. Therefore, the object will keep rotating and it will stop after a while. But for some time, it will rotate. No? While it rotates, without we pushing it, how many forces are acting? Right. So if this angle is theta with the vertical, this angle is also theta with the vertical, then you can take the components. No, this is going to be t cos theta, and this is going to be t sin theta towards the center. So who is the centripetal force here, people? Who is the centripetal force for the system? Centripetal force is going to be who? T sin theta. Hope you guys understood that. It is not an additional force. You shouldn't mark centripetal force as a unique force. You just mark the normal forces acting on the object. Then you find out which force is directed towards the center. And then that will be named as centripetal force. Okay. Right. Let's try one more. Example 2. Let's see who is giving me the correct answer. Now imagine a system like this. There is a cone-like structure like this. There's a cone-like structure. Okay. Inside that structure, we are allowing an object to rotate. So wait a minute. Yep. Okay. Cone-like structure, right? And the object now it's rotating this way. Somewhere the object is here. And the object is rotating like this. Okay, right. Let's make it rotate like this. It's rotating like this. Now tell me, wait. Let's say this is a smooth surface. This is a smooth surface. How many forces are acting on the object? How many forces are acting on the object? How many forces are acting on the object? Okay, go ahead. 3 responses, only one is correct. There are only 2 forces acting on this object. That is, one is weight. I'll mark it in blue color like I did earlier. One is the weight. And the other one is the perpendicular reaction like this. Perpendicular reaction like this. Okay. So for the perpendicular reaction, you can take components. if you take this angle as theta, this component is going to be r cos theta, and the vertical component is going to be r sin theta. Now tell me carefully, who is the centripetal force for this system, people? Who is the centripetal force for this system? Hurry up, please. Yeah, good. Centripetal force for this system is going to be r cos theta. Very good, right? You people have got it now. Fine. Okay, right, good. Now I'm going to put another structure. Now, until Azan finishes, I'm going to put another structure, and you have to find out which one is the centripetal force. Huh? Right. The three forces acting here, only three forces will be acting. Weight, obviously weight is going to be there. There's no argument with that. And R will be there perpendicular to the surface because there is contact between the object and the surface. So R. And this is a rough surface this time. Therefore, the object will try to slip downwards because of the component of weight. To stop that from happening, there will be a frictional force. So let's use F for the frictional force. Right. Now the question is, what is the centripetal force? To find that, you need to take components. Okay. Now for that, the wisest thing to do is considering line like this, and then considering another line like this. Okay. Now for that, you have to be absolutely sure about the angles. Angles, right? Fine. Now tell me, what are the angles, guys? Okay. What is this angle? Can anyone tell me? What is this angle? What is this angle? What is going to be this angle? That is going to be theta. Great, very good. Yeah, why is that? Why is that? Corresponding angle. That is the corresponding angle, theta. Okay, this line, parallel lines, so theta. If this is theta, can someone tell me what is this angle? If this is theta, what is this angle? So we need that angle, don't we? What is that angle? That angle is also theta. That angle is also theta. This angle is also theta. Why is that? This is theta and this part is 90 minus theta. Okay. If that is 90 minus theta, this total is 90 here. This is also 90. Now there are two 90s. This one is 90. Between R and F, it is 90. Between this broken line and this broken line is also 90. Therefore, theta, 90 minus theta, theta. 30, 60, 30. This is also theta. Okay. Right. So this 90 minus theta is not very significant here. We need to really know which one is theta and which one is, which angles are theta. Right. Okay. Now let's take the components for the forces. And if we take the components for the forces, I will use perhaps red color to make it crystal clear. Right. The components, one in this direction, that is R cos theta. And for F, there will be one here, that is F sin theta. And upwards, there will be two from R as well as F. So upward force we get from R, what is it, people? What is it going to be? The upward force we get from R, what is it going to be? That is going to be R sine theta, isn't it? R sine theta. That is going to be R sine theta. So I can mark R sine theta. And what is the upward force we are going to get from F? F cos theta. Good. F cos theta. All right. Nice. So you can see, a lot of things, but it's okay. Quite manageable, isn't it? R sine theta and here F cos theta. Good. Now, one thing I forgot to mention here, people, not only the centripetal force, we need to balance the weight also. Weight should be balanced. Here, weight will be equal to, in this question, weight will be equal to who? T cos theta. In this one, weight will be equal to R sine theta, because the object is performing a horizontal motion. Therefore, there can't be resultant vertical forces. And here, so let's start with centripetal force. What is the centripetal force here? Let's see who's giving me the correct answer. What is the centripetal force here? Okay. What is the centripetal force here? R cos theta minus F sine theta. R cos theta minus F sine theta. Because there is an F also in the same line. Don't forget that. Resultant of two forces or two components. Not only that, careful. Yeah, R cos theta is towards the center, but F sine theta is exactly in the opposite direction. So you have to subtract that. And can you tell me what is W equal to then? W will be equal to, we know now, downward force must be equal to upward force. Therefore, what will be W equal to? Downward force, that is equal to the upward forces. That is R sine theta plus F cos theta. That is how it works. Okay. We will be doing the exact same thing again, but I just wanted you to give an idea about how to mark centripetal forces and stuff. And now the next example we are going to discuss is it's similar to these things. It is from a model paper question, example 4. Imagine, not a model paper, right? Fine. Now these stuntmans are then available. These stuntmans, I don't know whether how many of you know. These stuntmans, they from outside they'll ride at a really high speed, and they will get into a circular road like this, and then vertical circle, then they can go like this. That means the guy will be somewhere here. Imagine this is a motorcycle for the time being. So the motorcycle will be here, and then the motorcycle will be here like this. Okay, and at this point the motorcycle will be here like this. You can see the motorcycle is rotating this way. All right, fine. Now tell me, what do you think is the centripetal force at this point? How many forces are acting on this object here? This is a vertical circular motion, huh? Right. What is the centripetal force acting on this object? Here. It will be centripetal force then, okay. No, it's a smooth one. You don't have to worry about the friction here. You don't have to worry about the friction. You don't have to worry about the friction, huh? You don't have to worry about the friction. Good. There will be two forces acting on this object, people. If you don't mark the friction, that is, one is W, the weight. One will be the weight. And the other one will be the overall perpendicular reaction, R. I'll take it as R itself. Now, on each tire there will be R. But let's consider the overall upward reaction, the R, right? Okay. And here, weight will be acting downwards. I'll mark the R. I'll mark this as R1. Here, there will be a perpendicular reaction like this, R2. Okay. And how about this point? W, weight will be acting towards the center, sorry, downwards, right? And R will also act that way. No, people. Both W and R will act the same way. I'll take it as R3. Okay, good. Now tell me, what is the centripetal force here? For this part, what is the centripetal force? Let's see who's giving me the correct answer. Centripetal force is equal to, okay, 4 responses, but only one is correct, unfortunately. What is the correct one? It is R1 minus W. Why are you forgetting about W? Why are you forgetting W? R1 is towards the center. W is along that line, people. You have to put the resultant force like we did here. Okay, here we put R cos theta minus F sin theta. Similarly, here we had put R1 minus W because W is in the opposite direction. Here, then tell me, what is the centripetal force here? Let's see who is giving me the correct answer. Centripetal force here. What is the centripetal force here for this point? Good. What is centripetal force here? Very good, very good. That is only R2. Only R2. Why? Weight is vertical. We need the force to be towards horizontal. Horizontal, right? Good. And what about this point? Now, carefully think and tell me what is the centripetal force here? What will be the centripetal force here? Here it will be W plus R3. I marked it as R3 because R will be different now. At each place, R will be different. That's why I marked in different values. So it will be W plus R3. Now, I hope you guys got a very good idea about how to identify the centripetal force and how to mark it. Okay. Right. Now, let's make things a little bit complicated. Now, imagine the bike is here. Now, if I draw the bike like that, okay, never mind. We'll draw the bike like that. Right. Now, the bike is somewhere here, people, at a random place like this. And if I draw a line connecting the center of gravity to the center, this is that line which connects the center of gravity. Yeah. Right. Now, what is the centripetal force? I'll take this angle as theta. Now it is creating an angle now. I'll take this angle as theta. What is the centripetal force acting on the, sorry, what is the centripetal force acting on the bike? Okay. What is the centripetal force acting on the bike? In case if they come across a situation, if you come across a situation like this, what's the plan? First of all, we need to mark the forces. Let's mark the forces first of all. Right. So there will be, guys, a perpendicular reaction. I will mark it in a bit colorful way. That way. Okay, right. This. Right. There will be the perpendicular reaction. We'll take it as R4. And there will be a weight. There will be the weight, W. Correct? There will be W. This is W, this is R4. And as you can see, R4 is towards the center. W, it's downwards, but still you can take a component of W, correct, people? If this is theta, what is this angle now? What is this angle? This is also theta because alternate angle, is it zigzag, alternate angle. So the centripetal force at this point, I've used a different color specifically for that point. It's a different case. What will that be? R4 is directly directed towards the center. So R4 plus, if you take component of W towards the center, that will also be in the same direction. So it's W cos theta. R4 W cos theta. Hope everyone understood. So I got that response from two of you. Good, very good. Others, I hope you guys understood that. Is that clear? Can I get a confirmation from others? Whether you figured, whether you understood why this is R4 plus W cos theta? Maybe you can raise your hands and confirm it, please. If you understood it. Right. Taking components. Make sure that you make sure you include all the forces which are directed towards the center of the circular path. Okay, right. But this is highly unlikely because it's a vertical circular motion. Highly unlikely in a final paper because normally in our syllabus they go for these horizontal circular motions. But safe to know. All right, fine. Then I wanted not this example. I was not thinking of this example, but suddenly I just drew it. But it's good that we discussed it. Let's go for something like this. Now let's go for another horizontal motion, horizontal circular motion. This time I'm going to go with a cylindrical surface. Right. So it's a hollow cylinder where inside the, in the inner cylindrical surface, we can expect a circular motion to take place. So let's draw it. Sorry. Okay. Right. And this is the cylinder. Okay, people. Right. Now I expect you guys to answer this. Now imagine there's an object rotating here. There's an object rotating here this way. How is that? On the surface. Somehow we are making it rotate on the surface like this. Now, tell me, first of all, let's start with this. How many forces are acting on the object? How many forces are acting on the object? And this is obviously, it obviously has to be rough. Obviously has to be rough. If not, the object won't stay here. Here, W can be balanced by R sine theta, people. Here, okay. But here, definitely has to be rough. Without being rough, you can't expect it. Right? How many? They are good. There are three forces acting on the object, people. And what are those three forces? One is definitely the weight. No argument in that. One is weight, and the other one is the frictional force. The other one is a frictional force, because object might try to slip downwards because of the weight. So friction is only the one which is stopping it, and the other one is perpendicular reaction, perpendicular to the surface. Sorry, perpendicular to the surface, like this. Right. So let's mark the forces quickly. This is weight. This is friction, and this is R. Now tell me, what is the centripetal force for this case? And forgot to mark, the object is rotating like this, circular motion. Right. Let's say what is centripetal force? Good. Two answers already. What is it? It is R. Perfect. It is R. Why is that? It is directed to the center. And W and frictional, centripetal force has to be towards the center horizontally. But weight and friction are not in the vertical direction. Therefore, we don't have to consider them. All right. Good. And weight this time must be equated to frictional force. Weight must be equated to frictional force. And also we can say friction is equal to mu R. Okay. R is the perpendicular reaction, something like that. Okay. Fine. So why did I explain you this question? Why did I explain you these things? Once again, I am emphasizing the fact that centripetal force is not an additional force. You just mark the conventional forces and then find out how many forces are along the direction of the along towards the center, the components and the forces. Now, if there's a force along that line, you have to consider that as well. Not only the forces towards the center, force away from the center as well. You have to take that and subtract that. So we did that here, and we did that here. Okay, right. Right now, last week I said the object doesn't really have to take the entire circular path. Even if the object is moving along just a part of the circular path, that means it is also a circular motion. Now imagine a vehicle. Now straight road becomes a curve. It goes like another straightening. Straight road becomes a curve and straightening again. Right. So this is a curve path like this. Curve, and then again it becomes straight. Okay. Right.